So this is 5.3, and this is interpreting and sketching graphs. Okay, so after this, hopefully you're going to be able to do these things. You're going to be able to apply graphs to functions. Before that, we should really warm up by analyzing graphs and making sense of them. Okay? And then you should have the ability to analyze and describe and sketch graphs. So this is the big point of this. And then understanding and describing y-intercepts and x-intercepts. Okay, so this is a brand new concept to you here. So let's look at example 1, just to kind of start off. So we should actually all really be able to read graphs pretty easily. Each person on this graph represents a person, obviously. So it should actually send each point. Okay, so each point is this individual person. Let's edit that. Explain your answer to each question below. So which person is the oldest? What is his or her height? So here we can analyze our graph. Look at our graph. So the title explains a lot. This graph explains the ages and heights of people. We can see clearly that this axis here is our height axis, and it's measured in centimeters. And this axis here is our age, and it's measured in years. We can see that we are going up by 4s. So that makes these 2s. So this would be 2, 4, 6, 8, 10, 12, 14, so on and so forth. And then even in between, we know these are 1 years old. Okay. So 1, 2, 3, 4, 5. So you always want to check and kind of analyze your graph before you even start asking questions. Okay. Here we're going up by 50s. So this must be 25 here. This would be half of 25, so 12.5, so on and so forth. So we might have to do a bit of estimating, but that's okay. So let's look here. Which person is the oldest? So here, well, we're looking for the oldest, and that would be the furthest along on our age. So it looks like our point furthest along horizontally is G. Now G lines up right here, and we know that should be 18. Right? So 16, 18, 20. And it's asking how old they are. So first of all, it's G. So point G. Okay. And point G, we can kind of plot their points here. They are 18 years old. And what's the height? Well, we got to do a little bit of math here. So here, this is going up from 150 to 200. So that means the middle, remember, each line represents an increment of 25. So this would be 25, 50, 75, 100, 125, 150. So this would be 175 here. And it pretty much falls roughly in between 175 and 200. So how do I figure out what this is? Well, it would be whatever the half of 25 is, right? Because this jump is from 25 to 200. So 25 divided by 2 gives us roughly 12.5. So this doesn't represent 12.5 years. It represents 175 plus 12.5. And that equals, well, that's going to give us 187.5. So I'm not going to give a decimal. This is going to be a little bit more of an estimate. I'm going to say this person is roughly 188 centimeters. Okay, and remember, this is measured in centimeters, so it's roughly at 188 centimeters. Now, recognize we could have represented this as an ordered pair. What's the ordered pair here? Remember, your horizontal stuff goes first, and then your things on the vertical axis go next. So if I represented this as an ordered pair, it goes 18 years and 188 centimeters. Remember, it's always your horizontal axis and then your vertical axis. Okay, so that's how to list. And we are going to learn these a little bit more later. These are called coordinate points. Okay, let's go to B here. So which person is the youngest? What is his or her age? Well, the person who's the youngest here, it looks like they're 0 years old. A, right? So at this point, point A is the youngest. And this is probably an infant. Okay, they were just born. They're not even 1 year old. Look at that. So they are touching the vertical axis. And we can see that they are roughly 50 centimeters. So an infant, so that means 0 years old. And this thing, or not this thing, this person is 50 centimeters tall. Okay, and remember, we can represent that as an ordered pair. So if we wanted to show that as an ordered pair, again, it's the thing that lies on your horizontal listed first, so 0, and then what's listed on your vertical axis, so 50. Now, which two people have the same height? So here, we can see we're talking about height now. So we don't care about the same age. It would not be D and E. These guys don't have the same height. E is 150, where D is 125. Okay, we want to figure out who lines up along the vertical axis. So it looks like B and C are both 100 centimeters. So here, the people who have the same height are people B and C. And what's their heights? Their heights is 100 centimeters. So they're both 100 centimeters. And we could list these as ordered pairs. We would list them individually as ordered pairs. So here, they share 100 centimeters, but B here starts at 2 years, and they are 100 centimeters. So this is point B. And I would just represent B and then show its ordered pair. So B is at 2 and 100, 2 and 100. C is at 3, right? So between 2 and 4 is 3. So 3 and 100. So 3 years and 100 centimeters here. So there's listing our ordered pairs, and we can see that they both have the same height. Okay. Which people have the same age? What is their age? Well, here, it wouldn't be these guys because they're different age. They're the same height, but they're different age. These two are the same age. They're both 10 years old. So here, E and D. And we could list them as ordered pairs. Okay, so here, what is D? Well, I'm going to represent D's point. So its horizontal axis point is 10. So at 10 years old, he is 170 or 125 centimeters. Now E. E is also 10 years old, but he is at 150 centimeters. So we can see that both of them are 10 years old, which is what we were asking. So they are both 10 years old. Okay. Now, which person, B or C, is taller for his or her age? Well, let's see here. B or C. Now this one's asking which one is taller for his or her age. So C and B are the same height. Okay, well, C and B are the same height, but they're different ages. C is 3, B is 2. B, I would say, is tall for their height because they're as tall as a person who's 3 years old. So since B is as tall as C, but younger, I would say B is tall for their age. Okay, and you could also see that in their ordered pair. So B is 2 years old, so if we kind of zoom in here, B is 2 years old, C is 3 years old, but B is the same height. So this B here is tall for their age. So that's why ordered pairs can be really useful. Okay, and there we have now analyzed this graph in a multitude of different ways. Okay, let's move on here. Now, I want to do a little, what can I do here? So we can explain x and y intercepts, okay? Recognize, we usually call this axis, the horizontal axis, the x-axis. Okay, so horizontal axis is usually known as the x-axis. Sometimes your x points aren't actually represented as x, but we'll get there a little later. This is usually referred to as the y-axis, okay? And that's your vertical axis. And oftentimes, where your line or your graph meets these points are very special points. Okay, so that's what we're going to do. We are going to be able to describe what the x-intercept means based on a given scenario. So our x-intercept is when, again, your point or your graph touches the horizontal axis, known as the x-axis. We also need to be able to describe, this should say y, sorry everyone, the y-intercept and what that means. Our y-intercept being this intercept here. So what does this represent given a certain scenario? Okay. Now recognize in ordered pairs, what would this be? Well, in ordered pairs, this is your x-intercept. Okay. Remember, ordered pairs, it's always your horizontal line, horizontal point, and then it's vertical point. Okay, so our horizontal point here would be our whatever our x-intercept is, but what's our vertical point at? Well, it's actually at 0. So that's the special part about an x-intercept. It's when y, or your vertical point, is 0. So this is our ordered pair of this point. Our ordered pair of this point was when our horizontal is 0, but our vertical is at the y-intercept. Okay, and we'll talk about that a little bit more later on. So let's review here. So we want to review graphs. So this is something you've done before in grade 9. So it's all about coordinate points. I've been referring to these as ordered pairs, and that is true. But when we specifically talk about a graph or a function or something later on, specifically graphs, we actually are calling these coordinate points. Okay. And coordinate points are formed by domain values and its corresponding range values. So here, just a little reminder, domain values are usually represented with x coordinates. Range values are usually represented with y coordinates. So here, the domain value is what's on the horizontal line, and then your range value is what's on your vertical line. Okay, so what am I saying here? And this will become more and more easier to understand as we go forward in this unit. But our vertical line here, this vertical line, this is known as your range as well. Okay, this horizontal line is known as your domain values. Okay, so you have lots of things going on here. So let's kind of list them out. So your vertical axis, so this one going straight up and down, this is also usually referred to as your y-axis. Something else it's referred to is your range. Okay, so your range is your vertical. Your horizontal axis is known as your x-axis. And this is usually represented, or it is known as your domain. Okay, so these are your domain points. Now remember, we've been talking about ordered pairs in terms of horizontal point and vertical point. Mathematically, we can just represent that as x and y. Okay, so what is our x point and what is our y point? This is what you mainly want to get used to, and we will be referring to as we go forward on. So let's review how to plot points. So here we're given a set, okay, and in that set, we're given coordinate points. So this is a coordinate point here. And remember, this front number is what's on your horizontal line, aka your domain. Okay, it's also the x coordinate point that relates to this range coordinate point or this y coordinate point. So let's point plot -2 and -3. So here, when my x or my domain value is -2, my y value is -3. So I'm actually going to be right here. So this is my -2 and -3 plotted on a graph. Let's look at this next one. So when my domain value or my x value is -1, so right here, I am at y of 0. So here, y is 0 on this line. So this is actually your x-intercept. So this is the point -1 and 0. And we just learned this is known as an x-intercept because it touches the x-axis or the horizontal axis. Okay, so we've done this one and we've done this one. Now let's do 0 and 3. So this is saying when your domain or your x value is 0, your y value is 3. So that's right here. And now we've plotted 0 and 3. And what did we just learn this is called? This is known as a y-intercept. Okay. That's where a point is plotted on the vertical axis or your range axis. Okay. Now 1 and 2 here. So when my x value is 1, my y value is 2. So you can also, if you have a hard time kind of visually seeing this, when my x value is 1, my y value is 2. So these points meet right there. So you can use little dotted lines to try and figure out where they meet if you need to do that. Okay, so this is 1 and 2. And then finally 3 and 0. So when our domain value or our x value is 3, my range or my y value is 0. So here we find it to be right there. And what is this called? This is another x-intercept. So sometimes you have multiple x-intercepts, which is a-okay. Okay, so you really want to understand how to plot things. If you don't know how to plot things, it's going to be very tough moving forward. Okay, so as a quick little review here, you have lots of things going on. We have just said that ordered pairs now can be represented as a few different things. It can be known as your domain value represented first, and then your range value. You can have your x and your y value, okay? And remember, this is always your horizontal point first, and then your vertical point second. These are all stating the same thing. Domain is what's found here. Range is what's found here. This is usually your x-axis. This is usually known as your y-axis, so x and y. And this is what you really want to get used to because this is known as coordinate points. So when you talk about ordered pairs, so here we've learned that these are known as ordered pairs. When you convert them onto a graph, these are known as coordinate points. Okay, so lots of new terms kind of coming at you at once. So make sure you're practicing using these words in your vocabulary as you move forward. So again, we will talk a little bit about this later on more in depthly, but just recognize that x and y intercepts, they sometimes or most of the time have a very special meaning to them, especially in context situations. So an x-intercept is where a graph has a coordinate point that exists on the x-axis, or known as the domain axis. So remember here, your domain is your horizontal line, and this is known as your range. This is your range, and this is your domain here. Okay, the x-intercept is the coordinate point when y-coordinate is 0. So essentially, whenever your line touches your domain axis or your x-axis, this is your x-intercept. Okay, and again, depending on the context, this can be a really important point. So here, we can see that this graph is Josh's car trip, and this is the number of miles from Josh's home. So it looks like he's 160. And now what's the problem here? Well, actually it states these are miles. So this is 160 miles he's away from home. It takes him 4 hours to get home. That's what this x-coordinate represents. This x-coordinate is time taken for Josh to get home. And that's what the x-intercept represents. Let's maybe look at a y-intercept. So the y-intercept's the same idea, but instead your graph is not going through the domain axis. It's when it goes through the range axis, or known as the y-axis. So right here, this happens when your x-coordinate is 0, or your domain coordinate. So here we have at 0 for our domain, we are at 160, okay? And again, these are usually pretty important points. So right here, we can find our y-intercept. And what does that represent? Well, that represents the start of Josh's trip. It looks like Josh started off 160 miles away from home. So Josh started 160 miles away from home. Okay, so that is our y-intercept, and that's what our y-intercept represents. Okay, so it's really important to understand x and y-intercepts. This will kind of follow you throughout the rest of math. So let's look at a quick example. The graph shows the distance a rock climber is from the base of a cliff as time passes. So here it's a little hard to see. This is the distance from base, and it looks like this is measured in meters. And this is our time in minutes. Okay. So what we have to understand and learn how to do is describe this graph. So what is happening in this graph? You have to have the ability to describe what's going on in a graph. So use the words climbing, resting, or descending to describe the climber is doing during the segment shown. So from here, A to B, it looks like he is starting and he is climbing. So from A to B, he is climbing, right? Because he is slowly raising how high he is. That should be from 0 to A. That's my fault. Because from A to B, he's definitely not climbing. We can see that his distance from base is not changing. So if his distance from base is not changing, that means he's resting. So that would be resting. Okay. And then from B to C, it looks like he continues on in his climb. As time passes, he slowly increases his distance from the base. So from B to C, he starts climbing again. And then from C to D, that's a really steep drop. Look at that. It looks like it took him no time to get from C to D. So what do you think happened there? Well, I think he might have fallen. He took a long time to climb and then he fell. So from C to D, he's descending. And I probably am going to put in brackets, he probably fell. Because the time it takes for him to get from B to C takes way longer. And from C to D, he drops in a very short amount of time. So he definitely fell there. D to E, he definitely took a rest. We can see he probably had to take a rest, a pretty long one. Because maybe he hurt himself or maybe he's just trying to get himself sorted. So he's definitely resting at that point. So that's D to E. E to F here, now we have a gradual incline again. So now he's taking a little bit longer to climb that section. So this where here he's climbing, okay? And then for here, he's probably climbing, and if we want to really describe it, he's probably taking his time here. Because here, it looks like he kind of rushed it, right, from B to C, and this must be a tough spot, okay? So from B to C, I probably am going to represent here, maybe he's rushing it a little bit. Just because he fell so hard, right? And then from F to G, it looks like he probably made it to the top because now he's just resting. So F to G, now he's just resting. And who knows, he's probably done climb. Okay. So whenever you describe a graph, learn what the graph is, read the title, read what your vertical or your range is known as. Remember, this is known as the range or the y-axis. This is known as the domain, okay, and that's the horizontal line. Recognize that this says it's measured in t, which is totally fine. It's still known as the x-axis, but in this case, your x values are actually t values, okay? So that's something that can feel a little confusing at first, but it is known as your x-axis still. Now, what does the x-intercept represent? So where does our graph touch the x-intercept? It actually touches at the origin point, okay? This thing is known as your origin point, okay? And your origin point, if your graph goes through there, that's not only an x-intercept, this is also known as your y-intercept. So your x-intercept, if we represent the coordinate point of this thing, well, when my range is 0, so remember, coordinate points go x and then y, or domain and then range point. What's my domain point here? Well, it's 0. And our range point is also 0. This is the starting point of climb. So he hasn't went anywhere, at least at base. So this is at the base. Okay. So now I want you to go and try out 5.3. Okay. In your textbook, it might feel a little confusing because this 5.3 here, we have skipped 5.2 because it actually makes a little bit more sense to go into 5.2 after this. So please check out 5.3 and see how you do. There's lots going on here, okay? You have new understanding of how we can represent coordinate points, what those coordinate points mean. You definitely want to practice in your textbook lots. Okay, have a good day.